Okay, so this video is going to talk about the normal distribution examples. Okay, but now you're going to be seeing either multiple choice free response questions, and they're going to be a little bit different, right? They're not just going to say like exactly, the mean is this, the standard deviation is this, what is blah blah blah. Like you're going to have to get a little bit more creative here. You're going to have to really understand the definitions and how this is broken up into those sections by standard deviations, 34%, then 13.5 and all that stuff, okay? So just really, really be careful with it. I would suggest you have the other curve, the one with all the numbers, the one that says 68%, the one that says 95%, just have that in hand, okay? Because that's going to be really important. So just a quick little reminder. 68% is when you're one standard deviation away in both directions. This one is two standard deviations away, and this one is three standard deviations away. Okay, the percentages, this is 34%, this one is 13.5%, this one is 2.35%. There's going to be some problems. We're actually going to have to try to figure that one out, but for right now, let's go ahead and let's go to the first example. So it says, on a standardized test, Kathy has a score of 74, which was exactly one standard deviation below. So that right there is really important, below the mean. If the standard deviation for the test is 6, what is the mean? So already, this is why these problems are different, right? In the beginning, remember, I always had these two bits of information. But now the question is asking for what is the mean, so I don't have the middle number. What I do have, though, is a standard deviation, which is 6, okay? So we need to figure out how we're going to be able to fill this out, right? Where you don't have, sorry, I'm trying to make that in the middle, where you don't have this number, okay? You have 6 basically, whatever this number is, we're going to add 6 and then we're going to subtract 6 on both directions. But now we actually have a little bit of extra information with this 74. So let's read the problem very carefully. So Kathy has a score of 74, which is exactly one standard deviation. So what that means is that her score is either one away here or one away here. But it's only one standard deviation. So it's only 1/6 away. But now what's even more important is this word right there, below the mean. So what that means is that it's actually not this on this side, because we know if we go to the right, we are adding the 6. And that means it makes it bigger than the mean. But it says that her score is below. So that means 74 would go right there. And now what you have to basically think about is, if 74 is after we subtracted the 6 from the mean, what is the mean, right? Some of you could probably already really, like, in a very fast way, figure it out. But let's just, think about what should the number be. So obviously, x, the mean, has to be bigger than 74, right? That's the most obvious thing, because it's on the right in this number line. Remember, always. That's one thing that I always like to think about. This is sort of like a number line, okay? So now, if the mean is bigger than 74, that means obviously it cannot be 68. It cannot be 71. And so now I'm left with two choices. I'm left with, is it 77 or is it what is it 80? And so what you can do is just, process of elimination, right? You can decide, well, let's imagine that it is 77, okay? Let's just imagine. If I am going one standard deviation away and I know my standard deviation is 6, that means I would have to do 77 minus 6 in order to get 74, but we know that's not correct. So that means that 80 has to be the correct one, and we can check our work, which is really nice with this problem, right? If I put 80 here and then I do, well, if I know the standard deviation is 6, I do 80 minus 6. Will that give me 74? And yes, it does. Okay, so that's why 80 is the correct answer. So you see, these are the different types of problems that you're going to have to be able to do when it comes to standard deviation and normal distribution. Okay, so go ahead and see if you can figure this one out. For those of you guys continuing, let's see what we got. So on a standard examination, Laura received a score of 85, which was exactly, so you see, 2 standard deviations. So it's telling me it's like 2 away but now it's above the mean. So now it's going to be on the right of the average, okay? If the standard deviation, so we have standard deviation is 4, and we're trying to figure out the mean, okay? So let me go ahead and let's do a quick little sketch. Honestly, it gets to the point where sometimes I don't even draw this like bell-shaped curve. I just draw like this bottom part because that's really what what we need to use. And so let's go ahead with the mean would go here, and where would the 85 go? So 85 is 2 standard deviations above. So there goes the first one, there goes the second one. So then that means 85 would go right there. Okay? So now you really just, it's like working backwards, okay? If this is 85, we obviously see that the mean is smaller than 85, but now you have to work backwards, okay? So if I work backwards, if I go back to 1 standard deviation away, I know I'm basically 4 away from it. So that means this one has to be 81. There's really no way around it, because in order for me to check if the 81 is correct, I can just add a standard deviation, which is 4. And so then that means, there you go, it's right. And so then all I need to do is just basically just keep working backwards. Like, there's no shame in you just saying, hey, I know I need to subtract, so let's go ahead. Because if you notice, I'm going to the left, which we know it's subtracting, and then on a number line, right? Going to the right is adding. So you just have to like really, really slow it down and think about what you're doing. And so then 81 minus 4, that's going to give me 77. So then I know the mean is equal to 77 for this test. Once again, I can check, is it actually correct? And I just do that by going ahead and putting it in here. So 77, I know my standard deviation is 4, and I know, remember, this 81, I'm not checking to see if it's at 81. I'm checking to see that I get 85 when I go 2 standard deviations away. So I'll do 4 twice, basically. So it'll be 77 plus 8. And does that give me 85? Yes, it does. Okay. So then that means my mean is 77. Okay. So there you go, right? Different type of problems. Just really slow it down. See if you can figure it out. For this question, let's go ahead and let's just read it. So let's see. The shaded area represents approximately 95%. So look, now we're working with the areas. So this here and this here, if I were to shade all of this, what it's saying is that this is 95%. Okay. If these scores range from 78 to 92, what could be the standard deviation? So this is where you have to start actually think about. Like, if you notice, they're not asking for mean, they're not saying anything about that. So you really have to think about what's going on here in the normal curve. So 95%, right? You need to go back to that diagram, the one that has all the percentages, and you realize that 95% is 2 standard deviations away from the mean in both directions. Okay, so what that means is I jumped 2 and I got to 92, and then I jumped 2 over here. I should probably do that in a different color, and I got to 78. So technically, right, even though the graph doesn't show it, there's like another line right here. Oops, sorry, that's so off. Okay, so let's go ahead. I'm just going to redraw this just so you can see what I'm going to try and do right now. Okay, so we're technically going from 78 to 92, and what I just figured out is that there's technically another extra like little lines here that I hadn't used or hadn't seen in this graph. So what we have to basically determine is, well, how many sections are there in this graph really that deal with standard deviations? So we know this here is the average, and so you're going to go 1 standard deviation, 2 standard deviations on this side, and then you're going to go 1, 2 standard deviations away. So in total, we went 4 standard deviations, basically to go from 78 to 92. Now, what you have to basically really think about it is standard deviation does not change, right? It's always going to be the exact same number. So for instance, if I add, 4, 4, or if I subtract 4, 4, or if I say subtract 3, 3, and then that means I have to add 3, 3. So basically each distance is the same exact distance. So that means we can do this in two different ways. We can check these, right? We can check every single one of them, or I can see what is the distance between these two numbers. And since there's 4 sections, I can just divide that into 4 equal sections and it'll tell me, right, how much each one distance is. So I'm going to go ahead and do both ways, okay? The first one I'm going to do is I'm just going to check the ABCD or whatever, the 1, 2, 3, 4, okay? So let me check the 3.5, okay? Let me check the 3.5. So if I start at 78, what it means, and after I was able to draw and understand there's 4 sections in there, that means if I were to add 3.5 4 times, because really think about it, that's how many jumps I need to do in order to get to 92, right? 1, 2, 3, 4, okay? So if I were to add it 4 times, let's go ahead and let's see, do I get 92, right? Now you can do it like that, or you can do, 78 plus 4 times 3.5, and I actually do get 92. Okay, so then what that means is that 3.5 is actually the distance. Now, I know that was like, oh, well, it happened for this case, but what if it doesn't? So let me go ahead and let's do the second one just to show you. So 78, and I'm going to add 7 4 times. And basically, like, what number do I get to? And remember, that's just because it's 4 sections. So it'd be 78 plus 7 4 times. That's going to give me 106. So what that means is that if 7 is the standard deviation, this number over here should have been 106, but it's not. So that means the 7 is incorrect, right? And then if you notice, if I do 14, it'll just get even bigger. 20, it'll even get bigger, okay? So that is one way of doing it. Now, the other way of doing it, which is personally my favorite, and the one that I really suggest you guys do, is basically this way right here. Look. We know it starts at 78 and it goes to 92, okay? So what that means is I can subtract these two numbers. I can do 92 minus 78, and that's going to be 14. So that means there's 14, like, the distance between 78 and 92 is 14, okay? That's what that means. Now, since I realized that, you're talking about 4 sections separating 78 and 92, what I can do is just divide that by 4. So because you're basically saying like, hey, you went 4 sections, but each section has to be the same distance because the standard deviations, they don't change in one problem. And so that's how you would get 3.5. And what that just means is that 3.5 is what you're adding every single time to go from one line to the other line. And that's why, this gives us the answer fairly quickly, as opposed to having to check like what we did over here on this side with the 1 and the 2. Okay, so there you go. This one, the answer is 1. It's A. Let's call it A, 3.5. Okay, so this problem was definitely harder. Okay, so if you had trouble, I suggest you replay this problem, ask questions, Canvas or Remind, just to really get the best understanding of it. Okay. So let's go ahead, read the problem, and see what you end up getting. Okay, so this problem, basically, it's kind of similar to the one we just did, right? The only difference is that instead of it being 95%, it's 68. So once again, we go back to what does 68%, how many spaces does this account for? And we go back and we see those, and it's only one standard deviation away in both directions. So technically there's no like extra little sections in there. There is only like just 2 sections, okay? So this actually makes it a little bit easier because we really just have 2 jumps. Like you have to think about what number can I add twice that'll take me from 50 to 80, okay? You could do it the same way we did before, right? Guess and check. Wow, that's super ugly. Guess and check, and then just see does it work. I'm going to go ahead and do it the shortcut one, the one I showed you, the second method, which is let's take the distance from both of the, basically like both of the borders. So it's 30. And now let's see how many sections are in there, which since it's one standard deviation away in both directions, so one jump there, that means you have only 2 sections. So that means we would divide that by 2. And so that means the standard deviation is going to be 15, which in this case it's B or 2 or whatever you want to call it. And then there you go. Okay. Once you get the hang of it, these problems become a little bit easier. Okay. So go ahead, see if you can figure this one out. They should be getting a little bit easier. It's pretty similar to the one we just did. 68%, 72 and 86, and the mean is 79. Oh, okay, they actually even gave us the mean here. So let's draw it out. The mean is 79, 72. Oh, wait, let me just back up a little bit because I'm not entirely sure about that. 68%. So 68% means it's one standard deviation away in both directions. Okay, so it was fine me drawing only one line away. 72 and then 86. What is the standard deviation? So, I mean, this is actually really easy because they gave us the mean, so we can really just say, hey, what number do I need to add 79 with to get to 86, or what number do I need to subtract 79 with to get to 72? I mean, the really nice part is it always has to be the same number. The only thing you're changing is you're adding or subtracting. So the standard deviation for this problem is 7. For those of you guys that want to do my shortcut method, you would do 86 minus 72. Notice how I'm not using mean here at all. And then whatever number you get there, you would divide that by 2 because there's only 2 sections there. Okay, so this would be 14 divided by 2 and then 7. Okay, so there you go. Let's go ahead to the next one. For this problem, notice how it says 95.4. We're just going to take that to be the whole 95% one because, in other videos I've mentioned that this is like a very basic normal curve. It gets a little bit more complicated with the numbers, a little bit more, accurate. But, for us right now, 95%, if you go back to the normal curve where it has all the percentages and it says it's 68, 95, 99.7, this is going to be 2 standard deviations away in both directions. So technically, right, if we go ahead and do it, it'll be mean right here. It'll be 1, 2 away, 1, 2 away. Okay, remember this has to be super symmetrical, but there you go. So this right here is the space for the 95%. Okay, so it gives me the actual number. So 24.6 right here, and then it gives me 37.4. And then it's asking for the mean. So you want the mean. And then you also want the standard deviation. So this problem's very similar to the other ones. You just need to find the mean as well. So just by me figuring this out already, I know there's 1, 2, 3, 4 sections. So I'm going to do the shortcut method. I'm going to do 37.4 minus 24.6. And I'm going to go ahead and divide that by 4 because there's 4 sections. So 37.4 minus 24.6 is going to be equal to 12.8. Okay. And after that, it'll be 12.8 divided by 4. So 12.8 divided by 4 sections, because remember, that's how many jumps it'll take for you to go from 24.6 to 37.4. And then that one is going to be equal to 3.2. Calculator, okay? And so now, there you go. We already have the first one. Standard deviation is 3.2. And now if I go ahead and I try and figure out my mean, all I have to do is basically just decide one thing. Do you want to use the 37.4? Do you want to use the 24.6? If you want to use the 24.6, you're going to have to go 2 standard deviations. Notice how you're going to the right, and so therefore you add 3.2 2 times. Okay? If you want to work with the 37.4, you're going to have to go 2 standard deviations to the left, and so that means you would have to subtract 3.2 2 times. Okay? So I'm just going to go ahead and do the 37.4 one, and I'm going to subtract 3.2 2 times, because that's how many standard deviations away it is from the mean. I'm just trying to get it to go back to it. And so I think I could do that by hand. I think it'll be 31. Okay? And so then that means the mean, oops, sorry, right here already. So the mean is going to be equal to 31. And then there goes our 2 answers. Okay? So, I mean, just really notice how these problems you're using really basic, simple math, but it's just a little bit different. All right, let's see. Go ahead and see if you can solve this one, and let's try it. So normal distribution, score of 57 falls one standard deviation below. Okay, that means it's going to be to the left. And then 81 is 2 above. Okay, so we're getting a little bit more specific here. So let me go ahead and let's just draw the curve. So we have the average right there, and then we have one. Well, actually, let me start figuring this out. 57, one standard deviation, so that means one step away, and then it's below. So that means here goes where the 57 should go. Okay. And then if I work with the 81, that means it's 2 steps away, but it's above. So that means it'll go this way. Okay. So it'd be 2 steps away. So then that means the 81 would go right there. Okay. So that there is really important. I don't want you to just start drawing lines and putting the 57, 81 anywhere. Really, really read the question carefully. So now this one is saying determine the mean. Okay, so we want to figure out what the mean is. Okay, that right there would be my final answer. Okay, mean. Score of this test. So notice how many steps or how many sections is it between? It's 1, 2, 3 sections. So it's 3 jumps. 1, 2, 3 jumps away. So I can do the shortcut. I could do 81 minus 57. And let me just slow it down here. Think about why we're doing this. In order to get the mean, I need to figure out what the standard deviation is in order for me to go ahead and do 57 plus it to get that one. But if I don't know what the standard deviation is, I can't figure it out. Okay. So that's what I'm doing right now. This is the work for standard deviation. Okay. And then I can just, add, subtract, or whatever. So 81 minus 57, and I'm using my shortcut method here, okay? So 81 minus 57 gives me 24, and there's 3 sections, so it'd be 24 divided by 3, which is equal to 8. So that means even though the question didn't ask for it, I needed to calculate the standard deviation as 8. Because now it's really nice because in order to get standard deviation, I can, once again, you can choose. Do you want to use the 81 and then go 2 backwards? Subtracting, or do you want to make your life easier, go 57 and go 1 to the right? Okay, I'm going to choose the easy one. So I'll do 57 plus 8, and then that's going to give me 65. So then I know that right there is the average.